So why are we dealing with sampling variability, or margin of error, standard errors, of the samples? How is it useful? How is it going to be useful for doing statistical analysis when we gather samples from different portions? This entire population here, and if we pick a sample of 10 from here, you get like certain data, and you pick a sample of 10 from a different area, you get different data, kind of similar but slightly different data. And you pick a sample of 10 from a different area, different portion of the population, then you get similar data but slightly different again. That's like a randomness, randomness of nature. It's like the part of the nature. How nature is. How is it important? How can it be useful and handy in research or statistical analysis? Okay, let's say we have some research study going on, and there's a population here, and of course there are too many people in the entire population we're interested in, so we just pick some sample from the population. Okay, and what we're trying to do is, we have this amazing intervention or training or treatment that we developed, and what we'd like to see is, if we give this training or intervention or a treatment to the population, let's say we're talking about the test score, for example. And what we're trying to do is, we give this test, a training or intervention or treatment to these people, and we're hoping that this intervention or treatment or training is so effective that their score will improve. That's what we're hoping for. So we give the intervention, we give the training or treatment to these people. They study or train, or they go through this training or intervention, and after that, we test them again. Then what if, let's say their test score actually improved, like before the intervention or treatment, or training, their average score was 50, right? But after the intervention, it went up to 52 points. Yay! 2 points increase. But then here we're gonna have to ask question, why? Wait a second, 2 points? 2 points, huh? Is it really because of the intervention? Is it really because of the training or treatment that we gave them? How can you be so sure that the treatment worked, and that's the reason why they got 2 points higher this time? That's where the sampling variability comes in. Okay, sampling variability means, without any intervention or training or intervention, when we sample from the same population again, their test score is going to be different. No intervention, no treatment, no training, no training was given to them, but each time they take a test, it's gonna be different. It's a bad example, because obviously next time they're gonna score better. So let's see. Okay, there's a sampling variability among the samples. So it's possible without the treatment or training or intervention, a different sample could actually score higher. Second time around, it's possible. Second time around, this 2 points difference is actually just a random variability that the people cannot be, things cannot be perfectly consistent. In nature, consistency or sameness doesn't exist. Okay, you try to do the same thing. You like you're a karate man or a kickboxer or something. You try to execute the technique in the same way, but each time it's different, slightly different. So performing in exactly the same way, perfectly same way. It's you know, actually, I would say impossible. Could be possible, but you know, I don't know how. And so this 2 points difference could be those, you know, variability, you know, a difference, you know, that could happen, you know, each time you do the same thing. So you take the test and you get 50 points. You know, you take the test again and you get 52 points this time. I mean, it's a bad example to say, you know, in a test, if you're given the same questions, you probably get better, you know. I think it depends on what kind of questions you're getting, but, you know, first time and second time, you know, because you can't perform something in exactly the same way, there could be a difference of, you know, each time. And this 2 points could be, you know, those variabilities could account for that 2 points difference, you know, without intervention, without a treatment training. You know, you could be scoring 50 points first time, second time 51 points, third time 52 points, fourth time 52.5, fifth time 53, or sixth time 49, 48, 47, you know. So these variability may be a part of the randomness of the nature, you know, natural randomness, natural variability of human nature, or the nature or life. So that's what it is, you know. So if we know the standard error, you know, that exists in the natural environment, naturally exists, you know, if we know how much the standard error is, you know, standard error which exists naturally without any intervention or external influence, you know, then if after the intervention and training the test score, you know, the improvement of the test score is within this natural error, then we could say, oh, you know, this improvement can be achieved without a training, because, you know, it could be due to a natural error. So our test, you know, intervention didn't do anything, or maybe did something, but, you know, it's safe to say our intervention didn't have any significance, you know, in this post, you know, test score. And that's how, you know, that's how the sampling variability, that's where the sampling variability, you know, fit in this entire you know, statistical analysis.